the load on the. Well, I don't know about your side, but here the use of ACs and high equipments is making the electricity not to be
Wow.
stable. Mm.
Okay, I think he meant that there has been low turnouts, like turn-ups in the classes. That's what I think he meant.
Oh,
Like,
all right, all
yeah,
right, all right, all
yeah.
right, all right. Oh, but why has it been so, Kelsey?
I honestly don't know, right? I really don't know. So hi Suleiman, thanks for joining in. So I don't know. I put a call across to literally everybody that signed up on the form, and I don't know. Some of them said they were busy, they forgot, da da da. Some people said that they normally have engagement by this time, so it's best I send them the replay link, of which I have been judiciously doing. So I don't know actually, but I'm grateful that we still have people that staying. Yes, that's very important. At least I've been seeing some consistency and some new faces like Suleiman. So I don't know, but we are going to get better, definitely.
All right.
All right.
Yeah.
Hi, Suleiman. Can you say hi to everybody?
Can you guys hear me?
Oh, yes.
All right. Just give me some time. Can you hear me now?
Yes, I can, Alex. I can.
I don't think we can share screen with Telegram.
You can. Let me just send you a screenshot right now. How to do it.
I am now showing how to share screen. To share
Um,
screen.
Okay.
I
I need
did
some.
this screenshot. Someone sitting here. No, thank you. Thank you. Thank you. Hope you know we are doing. Sorry.
Hi, Suleiman. Hi, Adebayo. Can you unmute yourself and say hello to the group?
It's Adedayo. Good evening, everyone.
Oh, good evening.
You're
Good evening.
welcome.
Good to have you
Yeah.
here, man. Okay.
Good to be here too.
All right. So we're starting in a few minutes. Let me send the link to Alex. Just a few minutes. So, um,
Have you sent me the link? Hello?
please check your WhatsApp. I've sent you a picture on how to do it.
All right. Cool.
Yeah. Okay. Yeah. Well, Alex is setting up. So I'm so happy that we have this turnout. I'm really grateful you guys are here. So, Nash, Suleiman, Cryptomaniac, and I think there are a few persons here too. Adedayo, welcome on board. How's it been going? Have you been able to look at the previous classes we did? Please let's know your progress before we proceed. You can unmute yourself and speak.
Good evening, everyone. This is Crypto Maniac. I've not been able to dive in deep, but I've actually scaled through all that have been done, and I'll start looking into them. Yeah.
Oh, so sorry, guys. Alex is trying to set up his stuff. So
I think I've seen it. I just left the call. Check it out.
okay, okay, all right.
So who is still speaking, or should I take the floor?
Yeah, you can take over.
It's no wahala. So how far now? Hi guys. So the last session we had, we just spoke on um basically programs and how programs work and the whole everything. But we not really build anything, or how will I call it? We not really okay. We showed some few workings, but we not really go deep down. So today we actually interact with one Solana program, and then I think that's all that we'll be doing today. Or if that's not what we're doing, we now basically interact with some maybe the wallet connect functions and all that. But I think interacting with programs should be the better one. So let me set up my screen. But before then, do you guys have issues like anywhere since the last call? Hello, can you guys hear me?
Yes, we can hear
Yes,
you.
we can. We are with you.
Hello, do you guys have any problem from the last session that we had? All right, all right, cool. So we are talking about how to go through a program and all that. We talked about IDLs. We talked about normal programs. Then we'll not really talk about how you can interact with them. So let me just share my screen. Okay.
Okay, please when you start sharing your screen, let me know if it's reflecting from my end.
Can you guys see my screen?
No, I can't. Okay, yeah, I can now.
Oh,
Yeah, we
it's
can.
too much. I think it's just mirroring everything I'm doing. If I want to stop sharing the screen, how do I do it? All right, all right. I'm sorry, I'm just trying to double around this whole stuff. It's just my first time. So, um, so let me. I think we should just start from somewhere. So this is an on-chain program, right? How we discussed on-chain I'm sorry, this is a program ID. So we discussed on-chain programs and then native programs. Native programs are basically programs that are built in on so why on-chain programs are programs that you actually create for yourself or that are already created but that can be changed and all that. So one of the advantages or disadvantages of is that native programs, although is editable, right? But basically you can, I'm sorry, although it's editable or that you can interact with them on the fly. But when it comes to chain programs, you need to know about the idea, how to query the data, and all that. So that is for that. So we are going to be interacting with one chain program today. I think basically once we get that, the other things will just come up. I'll send you guys documents and files to read up on how to interact with Solana programs. So we talked about mainnet, DevNet, and all that. So this is DevNet here. We've been interacting with this. No. So we'll be interacting with this on-chain program. We talked about idea. So if you look at this on-chain program, we have the VBA involved, the instructions involved. This is initialize. So basically everything we discussed last week. So this initialize, deposit, withdraw, deposit SPL and everything inside. And then when you need accounts to interact with, these basically the accounts that are needed to interact with this on-chain program. So what we're doing today is to initialize an account here, and I'll show you guys how to do that on Solana. So basically, let me just reiterate. This is basically a program that has been written that anybody can interact with. But for you to interact with this program, you need to know like the instructions and just like a function on JavaScript. Sorry, an object on JavaScript that you need to know a class. I'm sorry, in JavaScript that you need to know the methods and all that. So basically, this is how we just know it on Solana. This is the initialize and all that. So let's just go down to some other things. I think we'll be writing much code today. So when you want to interact with this first, you will need your 3GS obviously for interaction, and it is written with Anchor. So I guess you guys had your Rust class and they talked to you guys about Rust and everything that has to do with Rust. So for you to interact with this, you will need. Sorry about that. You need to have your Anchor Anchor package installed, right? That's Cura X the Anchor package, so that you can interact with this program. And then the ideal is the ideal. So let me show you guys how this ideal stuff works. So for the ideal, coming. So basically this how so when you have TypeScript, there's what we call interface. For those of us that don't really know about TypeScript, what we call interface. If you're using JavaScript, you just import this and export it, right? But now this is the interface for this program that you want to interact with. So basically what you have to do is you get this, you copy this just from here. Right, and copy it, you come here and you paste it. So when you paste it, the whole aim of this is that when you're going to be interacting with it, is more of so it's more of just calling the object and then interacting with what's inside. So this is where we now come down here. So basically we talked about if you want to make call an instruction, so then you have to sign a transaction, and for you to sign this transaction, you need a key pair. And the key pair is just made up of public keys and private keys, right? Together. Now we pass it into this anchor provider function. Right, so this is the provider. And don't forget we have to make use of RPC. So the one of the major things RPC does is help you index your transactions and push them to the Solana blockchain, right? Instead of you writing those stuff from scratch and then indexing them and putting them on the Solana blockchain, this RPC help you to do that, right? And then we want to know when we want to get this transaction, or we want it to land on the blockchain and then give us back information of whether it's successful or not. when it's confirmed. So that's already the commitment confirmed, right? So that's basically here commitment. So I'm going to be using confirm. So this is TypeScript. I know most of us are not writing TypeScript. So basically explain most of how this thing works. But it's just the same way when you want to write it in JavaScript. So this is where you move down to the anchor provider and all these stuff that we imported here. So one of the importance of this anchor provider here is so that we can integrate this connection and this wallet keeper. So basically, instead of you to be passing in your keeper to send the transaction, you now pass this provider. So the program will be interacting with. So since this is TypeScript, you have to put in the interface. If not, you don't really need this, right? But you need to put this if I assume you are using TypeScript. So we just pass in the IDL that we imported, and that IDL is this, right? So to tell the program, oh, this is the format of the program that we want it to interact with. So whatever you're doing, it should be in this format, right? So after that, we will now pass in this provider. So what's the aim of this provider? To help you sign and to help you sign the transactions or the instructions that you're going to be putting out. So this is where everything now comes in. So um, let me split my screen. Let me split my screen. I think that will be better. So we'll start here, vault state. So if you see these instructions here, if you want to interact or if you want to initialize an account here, there are some accounts that are needed and you don't just know them by on default. One of those accounts is the owner account, right? And whether it's mutable is true, is the signer is true, right? And another account that you also need is the vault state account. Whether it's mutable true, whether it's the signer is true. So it has to be a key pair. So basically it's going to be two key pairs that will be signing these transactions. And then how do you know how to create these vault state accounts, right? So this is how you know to create a vault state account. This is it needs a vault state account, and basically it's going to be the owner of the transaction, and then to create the PD of the vault state, the account to create the PD of the vault state is going the kind is going to be account and the type is going to be public key, right? So basically, see it here is when you want to start, the name is the vault state account. It's telling you this account is mutable and it's going to be true. And the PDA that will be passed in the seed, right? Here is the account, the type. Sorry, here is going to be where is it again? Sorry about that. The vault state. Okay. Seed. Sorry about that. So here is the account, here is the public key, and the account is vault, and the path is vault state. So basically, looking at this will tell you how this program is going to be like. And then this vault state, keeper.generate, and then basically your vault public key is this, right? So it's the same thing as when you imported this keeper from here and running your keeper.generate generate. So what I'm saying is that already the code is here already. I don't want to start going from everything from scratch because let me not just make much complaints. So I don't know if you guys are getting what I'm saying because it's going to be a little bit complex today. If you don't understand our last class, that was why I went very deep, like not writing any code or putting hands on anything and just doing straight up explanations because today will be more of explaining how these things work. So the vault state, when you do your keeper or generate, don't forget that is a signer. So that's why it's going to be a keeper. And then for the vault, for other things that are depending on it, that's where you will now start using the public key attached to it. So let's go for this. So vault alt. So here you see that vault alt is mutable first, is a signer first. So basically it's going to be a public key, right? So if you come here, you see it kind is a constant type string, value is alt. So basically the seed that you pass into the program. So we've not really talked about PDAs. So program derived addresses. So program derived addresses are more of addresses that are found on the core, right? So these addresses not like your normal public address and private address. They are derived from programs. You can't just derive them on your own. You get. So that, and then what makes use of these addresses are not just your wallet. It's just the programs that you attach to it. That's how program derived work. So if I have a program that does, let's say, send a transaction for me, it can basically, with that program, it can basically spin up public keys on its own that it can be interacting with, right? We call them PDAs. So that program now have sole access to those PDAs, can tell it what to do and what not to do. So that's the way PDA works. You can't just, it doesn't have a public key, it doesn't have a private key. Instead, you find them on an elliptic curve. So the more this thing goes up, that's how you figure it out. That's a little bit complex. So, but how you how you can find them is by using what we call seeds, right? So those seeds are actually in form of what we call a buffer. So when you want to find the PDA, you basically use public key dot find program address sync, right? So when you call the public key and the method of find program address sync, that's where you're now passing the um, variables that are meant to be inside. So passing an array and the program ID. Hello, can you guys hear me?
Yes, I can.
Yes.
I just that the call is overwhelming, but as I asked the first question, whether you guys actually followed up on what we did the last class, that we are just doing more of talking than hands-on. So because if you don't really get that class, you won't really get this one. That's just it. So but so for us to figure out this, we have to go to the IDL and see, okay, I want to find the vault of PDA. So what is the seed that we use to find it on that epileptic curve? And that's basically auth. So when we pass in this auth, right, and then we pass in the vault states dot public key, right, to figure out this vault auth. Look at it. This is how we can figure it out. The vault auth is mutable false, is signer false. The PDA, how to generate it. That the PDA that is requiring a value, and then the value is going to be a string, right? So we pass it into this buffer, and then it needs a kind that is an account, and then the type is a public key, and then the account is vault, which is this vault account that we created here. So we basically pass in the vault public key inside and also convert it to buffer. So what this array carries is just the array just contains buffers inside, buffers of the requirements of those PDA. So when we are done with that, we now pass in the program.program ID. So the program.program ID is the program here that we have passed in that we want to interact with, dot the program ID of that program. So why I'm using this array and zero is that we are supposed to destructure it here. But instead of destructuring it here, we can basically still get the value of it here by just passing an array with zero. So it gets the first value inside this find program async. So this is the same thing we will do for this vault. Basically, when we go to the vault, we see that it's vault, whether it's mutable, it's true, is a sign or false. So basically, it's not going to be a key pair. It's going to be a PDA with a kind of constant type that is string and then value of vault. So this vault, this value is basically what's going to be inside that your buffer, right? So, and then the second one kind of is an account type public key. The path is also vault auth. So basically, we are now going to be using the public key from here. Don't forget, and that public key, we've already gotten it through this. So all we basically do is to just do vault auth dot to buffer because already we are already returning a public key here. This is the way it works. I'm not saying that this is how it is here, but when we destructure it and get the zero, the zero array of it here. That's by the structuring. What we are getting is the public key. So instead of calling vault auth dot public key dot to buffer, we'll just go straight to vault auth dot to buffer, call the function and the method, and then we go over to the next thing. So that's basically all the things that the accounts that are required in this program for it to be able to work. So when we are done with that, we sorry about that. So when we are done with that, we can now call our program, like interact with it. So basically, to initialize, to call the first initialize function, don't forget that we need to get these accounts that are required. Look at it. These are accounts that are required to run this. Look at it. These are accounts that are required to run this, not the arguments. So basically, when you now want to do it, you just call the initialize function dot account so that you can pass in those required accounts that are in. Now, this is where it gets tricky. So the owner, right? You first and pass the first account, the owner, which is your wallet address or the signer. That's why you pass the key pair of public key. The vault state, you pass the vault state of public key. This vault auth, which we already decentralized and destructured, right? We pass the public key to. If you have not destructured, you just pass. If you have destructured, you just pass it straight up. But if you have not destructured, you pass it in with the public key. So, and then since it's a token, don't forget the last class I told you guys that any account that you are running with and it has to do with tokens, you must pass in the system program account. So the system program account is just like a native program that must run on anything that has to do with tokens, right? So you just put in the system program ID, and then this is where the signers come in. If you check here, it says is a signer true. Here it says it's a signer true. So far that these two things are signers, you must pass them in as the signers in this part of the signature. And then you call your RPC. So your RPC is basically this, right? But everything is baked in to this anchor provider. So if you just call it here, it just runs. So when you want to do that, okay. So when we want to do that, basically on the note, on our package.json file, we already have um, commands or our scripts already written. So that's just like sorry. So if I want to run this file, I basically the initialize file, it is a TypeScript. We are supposed to do ts node.cluster.this.this, but we just shortened it to vault in it. So basically just do yarn run. If you're using npm, just like npm run this. So basically yarn run vault. So before I run this program too, you have to have your Solana in that wallet address that you're going to be using that will run this program, and you'd have imported the wallet that will be running this program. So basically, when you have this tool, this DevNet tool, so one of the places you can get your DevNet tool is here. Um, that's if you want to do it this way. But apart from that, you can just you have your connection.rpc, so you can just do dot request airdrop. You pass into the public key that you want to receive the listing and the number of SOL that you want, and then it just gives you one airdrop. It doesn't do more than that. Just airdrops like one SOL to you. So that's how you can get one DevNet SOL airdrop to your account. So basically, so that's the way you just get this DevNet SOL to your account, right? So for us to run this program now, we do our yarn run vault in it, and let us see. So basically, it gives you a success, right? So basically, that's the same thing we do when you want to do your vault withdraw, vault close, vault deposit, and everything. So as much as is required in this program here, which is the same thing here, which is the same thing here that I showed you guys the last time. So basically, for you to run it again, let me reiterate. If I want to call this initialize function, right? It has account. So I told you guys, Solana runs an account model. Whatever you want to do, you have to save it in those accounts, right? So far you want to write to the blockchain, you have to like pay. You have to pay for rent, right? So just like having your account number. So when you pay those rents, you now store those information deep down inside that account. So that's the way Solana works. So for us to call this function, it has to create some account that will enable it to run. That's why we now have to. How do we now create these accounts? That's another question that comes to your mind. So some of these accounts requires what we call PDA, program derived addresses. Some don't require this PDA. Some just require you to just do your normal public address or your normal key right? So if you to know one that is a signer, right, it's basically on the program you see where it says the signer is true. Why the other one will say if it's mutable, it also tell you that it's true. Then if it's a vault state, it's sorry, like this vault state too is it says the signer is true. So whenever you see signer is true, it means that it's going to be a key pair. But whenever it says the meter is mutable and true, it's basically modifiable and all that. So basically these two things goes on with whatever that is going to be a key pair, right? But now when we have this mutable false and the signer false, so basically we are going to be talking about either PDAs, we are going to be talking about public keys, right? That's the way this one works. So, and then if you're talking about vault, this one is also mutable true. That's basically either a public key or a PDA. So when it's mutable is true, it can be a public key or a PDA. But when its signer is true and mutable is not true, it's basically going to be a key pair. So wherever you see there is a signer, that's going to be a key pair. But if the signer is false, it's basically a public key or a program derived address. So program derived address, as I said, are just like public keys that are owned by the program, right? You can't just own your PDA. These programs that own PDAs. And how to find PDAs is by knowing the seeds that they were created with in that program. So if you can't get the seed that it was created within that program, you can't really get it and you can't have access or control over it. So basically that's the way it works here. So now when we run it, let's check. So it tells you that you've initialized the account. This is the owner of the account. You signed and then you added plus 0.001 so to this for creation of the account. So this is the system program account that helped in running it. So this is the instruction that we just run now, the initialize instruction. And then this is the owner. This is it here. The vault date. This is one of the accounts you created. The vault authority. This is it here. The vault itself, this is it here. So you can basically see that these two are PDAs, right? And then the system program, all these are accounts that we are required to just run this initialize instruction. And then you see that the success program is the program returns success because it initialized the instruction. So basically that's the same thing. If assume we wanted to deposit SPL, it means that we have to create our SPL token first and then know how we are going to deposit these SPL tokens here. So I think this is how you can interact with Solana programs on the front end when you want to build your front end applications. So basically, if you are going to be building with React or whatever stuff you're going to be building with, basically it's almost the same way you're going to be doing that. Only that when you want to sign your transactions, maybe you now have to serialize it and send it over to the wallet provider, be it Phantom or MetaMask or whatever, to sign. Sorry, for using MetaMask, Phantom or Souffle or Backpack to sign and then return whether it's a success or not. So when it returns, it doesn't know whether you successfully signed or you did not successfully sign. So I think that is it for the call. I don't know if you guys understood it. I'm still going to be in your community, so if you have questions where you are having issues, you are free to send me a DM, and I'm also obliged to answer. So I don't know how you guys, whether you guys understood what we did today, or you can just basically reiterate, try doing it yourself if you have something or any issue with it, come back and you know I'll help you guys around. Carlson,
Yeah, I'm with you.
so what's up? I think I have another
You
meeting
don't?
scheduled. Right. Hello?
Okay, you have another meeting.
Yes, very soon. So is there any other thing that we have?
No, there's nothing. Like,
So do
we
you
done with the class.
yeah, I just explained how you can interact with programs. If you guys have questions, ask. Let's say 5 minutes. 5 minutes and then
Sorry, what did you say? I didn't get you.
okay, I'm open to listening to you guys' question just for 5 minutes. Then after 5 minutes,
Okay.
Can you hear me?
yeah, I can hear you.
Okay, your audio was kind of low throughout, but I
Oh, you would have, oh God, you would have told me.
yeah, I actually posted it on the chat. I didn't know you didn't see it. But yeah, it's not much of a question, more like a suggestion. I don't know if you can like start a beginner project afresh so that
No,
everybody on the channel can like work on the project together. I think like make commits, make pull requests and stuff like that. Maybe like that will be able to like obviously be able to get errors, get questions to always ask you and stuff like
so
that.
I'm going to be pushing this file, or I'll send you guys into the repository, and then you guys can now interact with it from there.
Oh, okay, yeah, that's cool.
Now, any other question? I think I should be jumping up now. Maybe
Would you have another class?
it depends on if they have problems. So we
Okay,
can't
that was
talk,
what you
right? So um, I think this might be my last class, but I'll be happy to jump on a call if they have issues on development. Hello, Kelsey.
Um, it's a very good presentation, but I per se I can't say I follow it very well. But I intend to go through the video again, try my hands, and then if I have challenges, I'll let you know, or I'll put the question to the platform so you attend to us.
All right, fine. Any other person?
Thank you, sir, for the class. Also, I want to ask, like, can this be done on mobile or is it strictly for PC?
No, I don't think you enjoy doing this on mobile. I think it just is on PC. Right, any other question? Hello?
Yeah, so did you say there is not you can develop it for mobile or
Whether You can use it for mobile. So basically, it's just
Yeah,
an MP package, right? So just how you interact with this. Basically, how you interact with it on mobile. It's just figuring out how you guys do it on mobile. But there's React Native. I don't know what you're talking about building on mobile applications or something else. Hello?
What I'm trying to say is like the whole setup, can it be like made on mobile? Is it available on mobile or is it strictly PC or only for
Okay, whether
PC
you can use your
users?
mobile phone to set it up and build on it. Hello?
Okay. Okay. You done, right?
Yeah,
Okay. Okay, we'll talk in chat then, if that's the case.
sure. All right. So what I was saying was that if they have issues with development, the whole aim of super team and community building is we help each other grow, right? So if any of them have issues with building, they can basically send in a DM. We have our developers channel and all that. I'll share it with you. That we can continue from there.
Okay, no problem. I've heard you. Alright, so I think let me leave you to go for your next meeting, right?
Sure. Yeah.
Alright, take care. Alright, bye guys. Thanks for coming on board. Take care, guys.